This is lecture series of ordinary differential equation ODE, and this topic is exact differential equation. That is, we will study what is exact differential equation. Okay, before going to study exact differential equation, first we have to know what is total derivative. First we will learn total derivative, okay, and then we will go to exact differential equation, and then we will take some examples of differential equation, and we will check whether that is exact differential equation or not. So this is our main objects, okay. So first you have to know what is total derivative. In mathematics, everything is depend on function. So let capital F be a function of two variable, be a function of two variable. Okay. Let capital F be a real function. You can write it be a real function of two variable such that first partial derivative is continuous. First partial derivative is continuous. So let capital F be a real function of two variables such that first partial derivative is continuous. Let capital F, so this is f of xy. So capital F is a function of two real variable, that two real variable are x and y. So it is written as capital F of x and y. So this is capital F is the function of two real variable x and y. What is the partial derivative? Partial derivative, that is derivative with respect to x only. So this is partial derivative with respect to x, and another is with respect to y. Okay, so this is the partial derivative. If you derivative with respect to it, then okay. So what is total derivative? Total derivative is denoted as small d capital F, and it is equal to partial derivative with respect to x of this function f of xy into dx, and this is partial derivative with respect to y, okay, and multiplied by it is dy. So no, yes, dy, and this is plus. Okay, so small df, this is the total derivative, is defined as like this. Okay, this is, so this is total derivative. If someone asks you what is total derivative, then you will say first condition is total derivative of what? Total derivative of a function. That function will be a real function of two real variable x and y. Okay, and ऐसा होना चाहिए such that the function have continuous first partial derivative. That means first partial derivative ये जो है और ये जो है, these two should be continuous. These two should be continuous. Then total derivative is defined like this. Okay, df, this is the total derivative, is equal first partial derivative with respect to x multiplied by dx plus first partial derivative with respect to y multiplied by dy. So this is called total derivative. Now we have understood what is total derivative. Now we can go to exact differential equation. So what is differential equation? Differential equation, it has two, you can express a differential equation in two manner. First is differential equation that is expressed in the type of derivative. So dy by dx equal f of xy, small f of xy, let's suppose. Okay, so this is also a derivative, okay, differential equation. Okay, now you can write this f of xy is equal a function m of xy divided by n of xy also. So any function you can write this in this fraction form. So you can write dy by dx equal m of xy by n of xy. So this is also a differential equation you can write like this. Okay, now the another way is, so let us multiply this. Okay, the another way is multiply this m of xy with dx plus, okay, so this is equal to n of xy dy. So this implies this, so you can write m of xy dx minus n of xy dy is equal to 0. But this is a function, you can this minus can be go to the this function, so you can write plus also. So m of xy into dx plus n of xy into dy equal to 0, and this form is called differential form, and this is called derivative form, this is called differential form. So this is a differential form of a differential equation. Now what is exact differential equation? The expression m of xy dx plus n of xy dy. So this is the expression. So the expression this is equal to 0. If you write is equal to 0, so this is a differential equation. It is called exact differential equation when this part is exact. This expression is exact. If this expression is exact, then this expression equal to 0 is called exact differential equation. Okay, so this part should be exact. But when we can say that this part is exact, this part is called exact if m of xy this is equal to this del x of f of xy, and this n of xy this is equal to this del y of f of xy. Okay, okay, so let us write this capital. So capital f of xy is this. This can be written as m of xy divided by n of xy. That means this is, from this we have obtained this. This is a differential equation. So this differential equation is this. So this is called exact differential equation if this m of xy is equal to this and n of xy is equal to this. Okay. Now then it is called exact differential equation. Now there is a theorem. The theorem states that if you are given a differential equation, this, let us suppose this is okay, how to check that this differential equation is exact differential equation or not? Now this is a very interesting thing that I am going to see. Okay, the interesting thing is this. You can do a very trick here. Okay, very easy. You can do a trick here. Let us suppose this is, you know only this m of xy, you know only this n of xy. Okay, then so you are given an exact differential equation. You are given a differential equation. Let us suppose that differential equation is this, and you know what is m of xy, what is n of xy. Okay, you are given. Let us suppose derivative this m of xy. It is already derived with respect to x. Now derive with respect to y, m of xy, and it will be equal to del del y of, already it is del del x f of xy. And okay, this with respect to y and this with respect to x, del del x of n of xy. So del del x of del del y of f of xy. Okay. And this del del y del, now notice here, f of xy is a function. You first derive this function, you first do okay, differentiate this function with respect to y, and then you differentiate this function with respect to y. This is same as first you differentiate with respect to y and then differentiate with respect to y. So these two, this and this, these two parts are equal. Okay, these two parts are equal. That means when it is an exact differential equation, then these two parts are equal, you can say. Because if exact, then you can write this m of xy is equal to this, n of xy is equal to this. So when you derive with respect to y, you will get this. When you derive with respect to x, you will get this. Okay, and now we have obtained that this is equal to this. These two are same. Okay, so that's why these two are same. If this right hand side of the equal sign are equal, then left hand side also equal. So this will imply del del y of m of xy, and it is equal to del del x of n of xy. That means, now this is the very important thing. If you are given this is a differential equation, simply you can do del del y of m of xy and del del x of n of xy. If these two are equal, then you can say this is exact differential equation. Okay, so now we have obtained a way to check whether a differential equation is exact or not. So this is a way. Okay, now we will check. We will take an example. So example, y square dx plus twice xy dy equal to 0. So this is a differential equation, right? Something into dx, something into dy equal to 0. This is a differential equation. Here m of xy is equal to y square, and n of xy, this is equal to twice xy. Is it exact? How to say it? Differentiate with respect to y. This, okay. Del del y of m of xy you will get twice y. Del x of n of xy, you will get twice y. Since del y of m of xy is equal to del x of n of xy, this will implies this differential equation is exact differential equation. So this type of differential equation is called exact. If this differential equation is exact, we can use a method to solve this type of differential equation. So okay, in the next class we will solve some differential equation which is exact. Now before ending this lecture, I will give you an example and we will check that differential equation is not exact. Y dx plus twice x dy is equal to 0. So this is a differential equation. Check. This is m of xy, and what is n of xy? This is second part, which is product of dy. So that is twice y. Derivative with respect to, if it is with x, then derivative with respect to y. So del y of m of xy. So this will be 1. Del x of n of xy. Okay. So there is no term containing x. So this is okay. Y will be treated as constant. So this is 0. Differentiation of this equal to 0. So that means this is not equal to this. So this differential equation is not exact differential equation. Another example. Twice x squared y dx plus thrice x y dy is equal to 0. Okay. So this is very easy to make non-exact differential equation, but it is complicated to make exact differential equation. So this is m of xy twice x squared y, and what is n of xy? Thrice xy. So with respect to y, and you will get twice x squared here. I hope you know how to partial derivative, how to do partial derivative. If you don't know, I will make a video. Okay, so it will be with respect to x. It's very easy. Okay, partial differentiation is very easy. So you will get thrice y. So twice x squared is not equal to thrice y, right? So these two are not exact. This differential equation, these two are not equal. So this differential equation is non-exact differential equation. So in differential equation, in this we will study the nature of differential equation, and if this is differential equation is exact, how to solve this differential equation. If it is non-exact, how to make the differential equation exact. So using integrating factor, you multiply using integrating factor. You can make the differential equation. You can convert the differential equation to exact. Then you can also solve the differential equation. And some differential equation is a linear differential equation that have a that have that linear differential equation have a special type of integrating factor. So we will study them. And some differential equation is Bernoulli differential equation. So that also have something defined way. And some differential equation is homogeneous. Then how to solve? And some differential equation is non-homogeneous. Okay, how to solve? Okay, so thank you. In the next class, we will study how to solve an exact differential equation.